Hydraulic actuated valves. It's time to talk about the newest thing on vehicles. Hydraulic valve lift for intake valve offers some real advantages for low emission. We'll explain why in detail on that. Better than an EGR. It gives us better fuel economy, and at the same time, it gives us great performance. Now remember the old rules? High performance, the hot rods of the old days, the high lift race cams. They had a lift of somewhere around 12 or 13 millimeters. That was done to improve airflow of that mixture into the cylinder. The result was very poor idle quality. You remember how cool the idle quality was? Because cool is the only word to describe it. Good certainly did not apply. Then we got a bunch of economo boxes that use lower valve lift to use less fuel. The problem was poor performance. You had to draw a line in the sand to see if the stupid thing was moving. Wouldn't it be great if we could marry the best of the hot rods with the best of the econos? We might be able to do that. Let me explain how. We've got to start off with throttle control. Hydraulic valve lift can be used to control engine speed without the use of a throttle plate. Hydraulic valve lift with use of very low valve lift at idle on the intake valve, typically around 2 millimeters of lift. Now this will limit the volume of air in mixture that can get into the combustion chamber. But some people say, isn't that a restriction? Yes, it is. It is a restriction. But let's talk about restrictions. The throttle we've had for years creates manifold vacuum as the engine works to overcome the restriction of the throttle plate that's nearly closed at idle. So it's restriction either way, one creating manifold vacuum, one simply reducing how much volume of air and fuel get into the chamber. Let's talk about that pumping loss and throttle restriction. Throttle restriction causes a loss of engine power to overcome the high manifold vacuum. We always said, hey, good high vacuum indicates the engine's running good. But creating this great high vacuum required the engine to do a lot of work, and that means there was a loss of energy. This loss of power is called pumping losses. Pumping losses is the resistance of air movement when air pistons pulls the air in and pumps it out exhaust. It's particularly high in the intake when the throttle is closed and we have high manifold vacuum. Going down the highway, we're driving on the highway, 2,500, 3,000. We still have the throttle plate slightly closed. They're not wide open, otherwise we'd be going faster than 2,500 or 3,500 RPM. The pistons are still trying to draw air in through the intake. It's slightly closed, and we still have vacuum. We still have the throttle is used to create a vacuum to resist the flow to control engine speed. We can do all that with lift. This wasted energy is called pumping losses. Let's get into this hydraulically actuated valve to see what's so magical about them. First of all, hydraulics are used to open the intake valves. You know how easy it is to use hydraulics. You take a jack, you can pump the handle down and lift a car. You're using the hydraulic advantage. The other advantage of hydraulics is it's easily controlled with electronic solenoids. We'll show you how we do that. We're going to take the solenoid so we have a small valve opening around 2 millimeters, like we said. Maybe it's 3. Who cares? We're not going to measure it. But we're going to use this small opening to control idle speed without a throttle plate. Yes, we're limiting the amount of air-fuel mixture that gets in. Particularly with ported fuel, we'll have finer droplets because there's a lot of turbulence in getting in past this 1 millimeter. We could go into a lot of technical details that'll tell you this is very efficient. The other thing we're going to do, this throttleless operation, meaning variable valve lift rather than throttle to limit the airflow in the combustion, does not create a high manifold vacuum. There's only a slight vacuum to pull the air through the manifold. It's not restricted. The increased valve lift can go as high as 13 millimeter for wide open throttle maximum power. Hey, here's our high lift race cam from the old hot rod days. We have access to it in a car which can get economy mileage, good performance. How do we solve this problem with better emissions? Well, let's talk about these better emissions. It's continuously variable to meet a full range of engine operation, but we're going to change the power output by changing the intake valve lift more, and it's more efficient, reduces camshaft torque because it's not having to work against the spring It's only working on hydraulics. And the maximum lift can produce maximum power, gives us a lot more stuff. We can use variable valve lift to control engine speed. We got all of that solved. And here's the kicker. Early valve opening creates overlap between the intake and the exhaust that allows for a little bit of exhaust gas to come in to give us internal EGR action to control NOx. How does this improve emissions? Well, let's go back and talk about sitting a EGR valve someplace in the intake manifold. We open it up and we hope it mixes equally with all cylinders. It never does. If you have enough EGR on the front cylinders to reduce their NOx, you've got too much EGR on the cylinders closer to the EGR valve. If you have just enough EGR in the back with a valve to fix the rear for good NOx, you have excessive NOx in the front. We solved that problem here. Let's see how. Let's go in and look at how we're going to control all of this. The intake cam lobe is going to drive a hydraulic piston to create pressure. And that pressure is going to be used to open the valve. So here's our lobe. Notice it's a nice high lift lobe. You can look at it and tell that. And it's going to be driving a piston. This piston is going to be a positive displacement piston. It's going to put out the same amount of fluid volume every time it comes up on the cam lobe. But here's the kicker. We're going to use a pressure control solenoid to vary that lift. We're not going to use all of the hydraulic pressure that's generated. This is going to be a pressure bypass solenoid. If we don't want to have the valve open early, we simply bypass it so that the hydraulic pressure doesn't work against the valve spring and the valve stays closed. And then when we're ready, we close the bypass so that it will continue. Any continued valve lift will start opening the valve. So we can pick what part of this lift curve we want to use. That's important. That gives us total control. For maximum power, maximum lift, the solenoid remains closed all the time, which causes the valve to follow the cam profile. And we get a profile that is going to give us full pressure, full high lift, high performance cam. We open it, we can release pressure. Let's see how this is going to look. The PCM is going to determine exactly the timing and the amount of the lift we're going to have. Here we have two of them. With the bypass valve closed, the pressure, which is hydraulic, follows the cam lobe, and it's going to raise and lower the intake valve just like the cam lobe. That's the blue curve. Notice there's a bunch of shadows underneath it because we can vary that, and we can do a lot of variation we got to talk about. Early lift, meaning lifting a little early in the cam, causes overlap between the blue and the red. The blue is the intake. It's intaking air while the exhaust valve is still open. This gives us our internal EGR. So the early lift gives us EGR. But look, the back end, we get early closing too. So we got EGR with the front end, and then we've got early closing. What's this early closing do for us? Well, let's look at low speed. If we close it early, we don't get much valve lift. So we're going to open the valve solenoid, which releases and bypasses the pressure, and the valve closes. We just opened the bypass valve early on this one. But if we didn't want to open it early, it would go all the way to the top. And if we want to open it partially, we can open it somewhere in the middle. Now we're showing 3 or 4 curves here. Understand, this is continuously variable. This is the way we control engine speed, is by how much we open the intake valve. And we've got lift conditions where we don't want EGR. Let's look at this. The idle operation we're pointing to right now with idle RPM. It's open later in rotation, away from the red exhaust valve, so we intake no exhaust gas. We have eliminated EGR. And it's a small amount of opening, which is typically around 2 millimeters to give us idle speed. And then we can move on up. We can go to low cruise. Look what starts happening at low cruise. We're starting to cross the red and the blue, the exhaust and the intake are starting to overlap a small amount, and EGR is just now starting. But let's talk about this EGR. It's not random, hoping it gets into each cylinder. This is EGR going into this specific cylinder. Now, all the cylinders in the engine are doing the same thing. But what this is telling us, all the cylinders in the engine are going to be getting the exact same amount of EGR. That's really important. That's how we can get lower emissions. And we can go on up and use more. So we can have low RPM, no EGR. Start moving up higher, we get into EGR. And higher, we get more EGR, higher speed. So EGR is just as controllable. And remember, the timing of this opening can also be changing EGR. And if we get really fancy, we can get into fine-tuning, like doing light load cruise. We use multi-lift operation. It's going to fine-tune the EGR rates. Now let me explain why this happens. Look, the same amount of overlap happens on all of them. And we're going faster and faster. Sometimes we want a little more mixture without any exhaust gas in it. To do that, we open it a second time. This gives us less EGR effect, so we can fine-tune this so we have the same starting point, but opening it, then saying, yep, I want more EGR or less EGR. If I want less EGR, I open the valve a second time and let a little more mixture in. This is fine-tuning. We don't want to get too crazy with this because this can get to be really technical. But let's summarize it. This technology is going to spread very fast. This hydraulics is better than the mechanical valve lift we have now. We've got some step function valve lift where they put a pin in and they use two different cam lobes. We've got rotating concentric cams that try to rotate the whole cam to vary valve lift. This is electronically controlled, works pretty simple. But this technology, like all the new technology, is subject to maintenance problems. If oil changes are neglected and we gum up the mechanism with sludge and varnish, it too is going to cause problems. So this should be giving you a good overview of all the new stuff, and we've got this divided into enough pieces, you should be able to find what you're looking for.